Well, welcome back to the Living Island, for those of you who are following, and welcome to those of you who are new. As I said last time, I'm getting into more and more information about what we discovered this past summer on the island as it pertains to climate change and the study of it. And one of the things that is being now looked at and recognized around the world is habitat loss. And it's one of the main causes behind the decrease in species itself and forest communities. Habitat fragmentation is, just think of that. You have a habitat and it breaks up, think of a puzzle, and you have these little fragments. And they become small and they become isolated from one another. And this happens in conjunction with habitat loss. So in a sense, if you cut a woods down, a very large tract where there's a huge fire or something like that, certain sections will not regenerate in the same way as it was. That becomes the problem. And the spatial division of habitats decreases the interaction of the local populations, because maybe that species there won't come back, this one come in, it's never been here before, things like that. And it generally has a negative impact on the population viability, and that becomes a real problem. Yet it could also be a positive effect, because for some species there won't be the same competition. So if they can remain where they were and the other guy doesn't, they're going to do okay. But habitat loss globally is, again, one of the biggest threats to biodiversity. It's often difficult to assess it, which component in the habitat loss eventually drives, say, a population to extinction, because the vulnerability towards extinction is generally known from the highest levels in the food source, and then low population densities. And if you have a slow life history, you don't come back in a big hurry, or a small geographic range, all of those, if you've been eating, somebody's eating on you in a big way, not a lot of you left, but it takes a long time to get there to reproduce, and you're squeezed into a little area, you got a problem. Now, wood-inhabiting fungi, which maybe you haven't given consider to, are known to respond to fragmentation as species abundance and the occurrence of particular species have been shown to vary along the way with forest isolation and then reduce size. They are known to depend on habitat availability at the landscape level. So we're looking at, not in the area that I'm looking at, but in a wider area, even to the extent of an island, which is 2 kilometers long. Special habitat requirements and low natural abundance are indicators for wood-inhabiting fungi, as both imply a low overall prevalence and amplifying the effects of environmental randomness. And that means to understand that these types of fungi are crucial in the breakdown of the dead wood, into its chemical components used for regeneration of the forests. And as this happens, the fungi, which is critical, the more it's impacted on these changes in the environment and in these little niches that they have, it becomes harder. The dead wood might take even longer to rot down to nothing. But the effects of that are not going to be there. That's the problem. Because specialized species, and this is that coevolution part, specialized species tend to be characterized by small spores. Now you're thinking fungi. Think of a mushroom. There's spores in those gills. And the spore shape is correlated to the spore size. You can look this up, don't worry about it. But spore dispersal, so when those gills open up and you get a wind and the spores go that way, it's important as how that determines the responses of a species to fragmentation. If the wind blows the spore, but what was there isn't, the spore dies. So what happens, in that sense? And for spore size, the fungi specialists that you would see on pine and spruce, which are dominant over there, are more specific in what's called decay class use, more so than what you'd find in other conifer dwellers or in deciduous forests, or simply generalist species that'll eat anything. You think of a crow or a seagull in that sense. However, the specialists are expected to be the first ones, like a panda bear. What happens if the bamboo goes away? Panda goes with it. So a specialist is expected to be the first ones that fall below their extinction threshold in the course of habitat fragmentation. And you got to see that as a whole picture. It's like if A goes down, B goes with it. And maybe C, and maybe D, because there's that effect that goes out. Many beetles, again, in this regeneration thing, don't really feed on the wood all the time. They feed on the fungi itself. And so you have a triangle kind of made up of the rotting log, the fungi decomposing it, and the beetles who eat the fungi. If the beetles go, well, fungi has a better time. If the fungi goes, that's going to take longer to rot. These guys have to go find food someplace else. That comes down to it. Everything is interacting because everything is related. That's the whole problem. As such, the reproductive and vegetative parts of the fungi serve as food for the beetles, but that could also act then on the magnitude and direction of the dispersal of the spores. And what happens is that affects the colonization of the fungi on the decaying wood. An understanding of, I guess, all of these interactions is important because the dead wood constitutes one of the most important structural components for maintaining biodiversity in the northern forest ecosystems like we have all around us here. The loss of deadwood habitat has really resulted in marked populations that are declining. And if you have a reduction in the diversity of wood decaying fungi and the associated insects, as hundreds of species of insects, beetles, what have you, come to these places and depend on them, mainly old trees, logs, snags, whatever it is, their survival comes into question. Now, these interactions show that drastic reductions in the amount of coarse wood and the insects associated with the decaying wood is major, and they could foreshadow a decline in the forests themselves. Because, as I said, you take one element out, it ripples through every other element. You take enough elements out, there's no more ripples. However, we have the chance to change ourselves and to work with nature. Get out there, understand it, do something. Until next time, take care.